computer. Yeah, I think that's it. So hello everyone, and welcome to this presentation about OCSP in EMQX. So here I will talk briefly about what is OCSP and what is stapling, and what we had to add to OTP to support it in EMQX, and then make a quick demo about how that manifests in practice. So first, what is OCSP? OCSP stands for Online Certificate Status Protocol, and it's an internet protocol used for obtaining the revocation status of an X509 digital certificate. So basically that means it's a mechanism to check if a given certificate is revoked or not. So instead of keeping track of certificate revocation lists or CRLs, a client or a server may ask the revocation status of a certificate to an OCSP responder using HTTP requests. And that, combined with stapling, which we'll talk about later, allows resource-constrained clients to ask a server to bear the costs of getting a response from the OCSP responder. And this protocol is defined in RFC 2560. So how does one get an OCSP response? First, an OCSP request must be crafted, and that contains the serial number of the certificate being checked, along with the name and key hashes for that certificate's issuer. This request is then sent to the OCSP responder server via an HTTP request, and that server keeps track of revoked certificates for the certificate authority that issued the certificate under verification. The responder then checks its database, searching for that serial number, and return its signed judgment about that certificate status that can be either good, revoked, or unknown. And then finally, this response can then be stapled into the TLS handshake for the other party to check. Then what does stapled mean in this context? Stapling it's a OCSP stapling. It's a standard that allows resource-constrained clients to delegate the cost of contacting the OCSP responder to the server they are connecting to. And they do so by adding a special status request extension to the client hello TLS handshake message. Then the server may perform the OCSP check either on the fly or using a cached response, and then staple such obtained response in a special certificate status handshake message, which is then returned to the client for its validation. Since the OCSP response can be cached for a given amount of time by the server, it can also reduce load on the certificate authorities, so they don't have to answer HTTP requests for each client connection all the time. And the format for the request is described in section 8 of RFC 6066. In this diagram, it illustrates the TLS handshake, and in particular, I highlight the certificate status message, which it contains the stapled response returned by the server. And it's important to note that this message is only returned if the client requests stapling. Otherwise, it would be a protocol error. So for the client to request stapling, it, as I mentioned, it adds a status request extension to its client hello message. And if you are using OpenSSL client to connect to a server, you can simply use this flag dash status to request stapling from the server. And this is just a sample response that comes back after decoding. So it contains information about the certificate being verified, and if the certificate status is good or revoked or unknown. And it may contain some validity to indicate that this response is valid for a given period of time. So what did we do to add this to OTP for use in EMQX? So our work was heavily based on Bran Verburg's work, which is described in this blog post. And then we added similar changes to our own fork, OTP fork. And that basically means that we use a specially crafted server name indication callback function to fetch the OCSP response either from a cache or on the fly, and then injected that into the SSL options to be used during the TLS handshake. So for this particular implementation, it means that the client must send the SNI extension for this to be triggered. Also, we needed to add some support for serializing and deserializing OCSP-related stuff, such as extensions and messages that are missing from OTP. And we did that for both TLS 1.2 and 1.3. So then if the client then requests stapling and the SNI callback manages to return a certificate status, then the server will inquiry a certificate status message between the certificate and key exchange messages while responding the handshake. So that's basically it. So we can then make a very short demo about how does that manifests in practice. So for this demo, I will spin up an OCSP responder locally using OpenSSL. I will then start an EMQX broker that has this patch applied, and then use the OpenSSL client to ask and check the OCSP stapled response to see what comes back. So first I will start the OCSP responders, so the message can be, the response can be checked by the server. I start the broker. And the OCSP response responder printed the response here, meaning that the server has already cached it. And then I will use the OpenSSL client to ask for the for stapling using that flag that I mentioned before. And note that I have to provide the SNI, the server name indication, for that to be triggered. And then during the connection, it prints some information about the handshake. And in particular, we have here the OCSP response that was returned by the server. And yeah, it's basically this that I showed before. And then just to illustrate, if we don't ask for the staple to be responded, the server should not respond that certificate status message, because otherwise it would be a protocol error. So if we don't ask for stapling, the server simply does not send the OCSP response in this case. Yeah. So that's basically it. So thank you. And if there are any other questions.
Yeah, thank you. I have a question. Is there another way to trigger the injection of the OCSP staple other than SNI callback?
Well, maybe we could use, I haven't tried that, but maybe we could use the verify callback that OTP provides as well. Mm-hmm. And then check if and trigger that when we receive the status request extension, but I would have to investigate more if that's truly an option, because we have to conditionally inject the certificate status into the handshake, checking if the client actually requested that.
Okay. I mean, if our customer is happy with this, then I guess we can start from here.
Yeah.
Okay. Is it verified at all by the user?
After the response is sent to the client, it's its responsibility to check the signature and if to check the status.
Is this feature validated by our customer?
Oh, I've sent them a beta containing this feature, and they tried it out and they said it seems to be okay so far.
That's great. Thank you.
Thank you. Any more questions? Is there something in the chat? Let's see.
No.
No?
I guess that's all then.
Okay, I will then stop recording here. Oops, I stopped the share.